8.1, multiplying and dividing rational expressions. Here's the objective. Let's start with our first example. When you're trying to simplify rational expressions, you want to look for common factors. So you'll need to recognize that the y plus 7 in the numerator and the y plus 7 in the denominator are common factors and they cancel. And what you'll be left with then is 3y over y squared minus 9. Now, if I were there with you in person, I would ask if you think that the y in the numerator and the y squared in the denominator, if those can be canceled or reduced. And some of you would probably say yes, but let me remind you that the answer there is no, because in the denominator, that y squared is attached to that 9 with the subtraction. And you can think about that subtraction, same for addition, as like a leash for your dog, and you cannot cancel that y unless you can somehow cancel the 9 as well. So this is, in fact, the final answer. Now, another way to think about this is if you were to take the original problem and rearrange it. If you said that's going to be 3y, and then I'm just going to leave some space and put the y plus 7 over here, and then I'm going to do the y squared minus 9 in the front, and then the y plus 7 in the back, then you can see a bit more directly that the y plus 7 over y plus 7, that's just 1, and that's why they cancel. Okay, let's take a look at example 2. This question is a little bit different. It says, under what conditions is this expression undefined? And this is the same expression from example number 1. Now, I need to remind you that a fraction is undefined when the denominator is equal to 0, because thou shalt not divide by 0. It's one of the 10 commandments of math. So what you want to do here is set the denominator equal to 0 and then solve. So in this case, we're going to say y plus 7 times y squared minus 9 is equal to 0. And we need to solve this. And in order to do that, I'm going to first factor that y squared minus 9, because that's a difference of squares. So that's going to be y minus 3 times y plus 3. And now I will set each of these factors equal to 0. So y plus 7 equals 0, y minus 3 equals 0, y plus 3 equals 0. So you're going to end up with 3 values for y. Y equals negative 7, y equals positive 3, and y equals negative 3. So those are the 3 conditions. When y is equal to negative 7 and 3 and negative 3, that is going to make that particular expression undefined. And let me illustrate why that's true. If you were to say substitute y equals negative 7, you're going to have, well, it doesn't really matter what you have in the numerator, but specifically in the denominator, you're going to have negative 7 plus 7 over negative 7 squared minus 9. Okay, don't know how to erase. See if I can. Oh, I got it to erase. Very good. Minus, come on. Oh, got to change it back to the pen tool. Minus 9. Okay, again, it doesn't really matter, blah, blah, blah is up there in the numerator. So in the denominator, you're going to have that negative 7 plus 7, which is 0 times whatever, but 0 times whatever is going to be 0, and you're never allowed to have 0 in the denominator. So that's why, in order to find when an expression is undefined, you just set the denominator equal to 0. Here's your first video quiz question. All right, example 3, we're going to simplify a different type of rational expression. This one is different than example number 1 because the expression is not factored for us. So we are going to have to factor. The only type of factoring that we can do here is greatest common factor. So from the numerator, I'm going to take out the GCF, the greatest common factor, which is a to the 4th. And when I take that out, I'm going to be left with b minus 2. And in the denominator, the greatest common factor there would be a cubed. And when I take that out, I'm going to be left with 2 minus b. Now, let's go ahead and take care of the a to the 4th over a to the 3rd. Of course, we know from last semester that when you're dividing the bases, you can subtract your exponents. So that's going to be an a to the 1st in the numerator, and then the b minus 2 in the numerator. Now, I'm going to do something a little bit different in the denominator. Instead of, I'm going to go ahead and actually make this an extra step. So that's 2 minus b. But 2 minus b is not the same thing as b minus 2. In fact, it's the exact opposite. So if I factor out a negative 1, I'll be left with negative 2 plus b in the denominator. And b minus 2 from the numerator is the exact same thing as negative 2 plus b. And now they are common factors, so they can be canceled, and you're left with a divided by negative 1, which is simply negative a. You'll want to pay attention to this technique here about turning 2 minus b into basically b minus 2 by taking out a negative 1. Let me write that again over here. 2 minus b is the same thing as negative 1 times b minus 2. Okay, you're going to see that in a few problems this chapter. And here's your second video quiz question. Okay, here's a key concept that's just simply, this is just a reminder of when you learned about fractions in middle school. That when you're multiplying fractions or rational expressions, you're just going to multiply the numerators and multiply the denominators. When you're dividing rational expressions, you're going to multiply by the reciprocal, it says there, of the divisor, which just means you have to multiply by the reciprocal of the second fraction. So here you'll notice that we did the reciprocal, so instead of c over d, it's d over c, and then you just multiply across the numerator and denominator. Okay, so let's take a look at a multiplication. We're going to start with some easier problems. I'm going to choose to go ahead and multiply across the top here. I'm going to show you a second way after I do this first way. If I multiply across the top, I'm going to have 56xy squared. And then when I multiply across the bottom, I'm going to have 336 x cubed y cubed. I just put them in alphabetical order. Now I want to reduce or simplify that rational expression. So I'm going to reduce 56 over 336, which is 1 over 6. And then I have 1x in the numerator and 3 x's in the denominator. So you're going to be left, when they cancel, you'll be left with 2 x's in the denominator. And you have 2 y's in the numerator and 3 y's in the denominator. So when those cancel, you'll be left with 1 y in the denominator. And I'm just going to clean that up and make it look a little bit neater. We're left with 1 over 6x squared y. Now, you could have, and this is usually what I do actually, reduced beforehand. Just so you could have reduced the 8 and the 16 to 1 over 2, and the 7 and the 21 to the 1 over 3. And then for the x's, you've got this 1x in the numerator will cancel with one of those, so that's going to become an exponent of 2. And then those 2 y's in the numerator will cancel with 2 of those, so it's going to become a 1. It's supposed to be a 1, looks like a dot. And then when you multiply across the top, well, you just have 1's in the top. And in the denominator, you've got the 3 and the 2 for your coefficients, so that makes 6. And then the y to the first and the x squared, so there's your x squared y. Okay, let's do a division problem. So remember, to divide, you need to multiply by the reciprocal. So that's 10m k squared over 3c squared d times 6c squared d squared over 5m to the fifth. I'm going to do this one the quicker way, that second technique I showed you in the previous example. I'm going to reduce the 5 and the 10. I'm going to reduce the 3 and the 6. I have, for the m's, I have 1 m in the numerator and 5 in the denominator, so if one of those 5 is going to cancel, so I'm going to make that exponent a 4. I have 2 c's in the numerator and 2 c's in the denominator, so they're going to cancel each other. I have 1 d in the denominator, so it's going to cancel with one of the d's from the numerator, so I'm going to change that exponent to a 1. And this k's don't cancel with anything. So in the numerator, I have the 2 times the 2, which makes 4. And I also have the k squared and the d to the first. And then in the denominator, all I have is the m to the fourth. And that's it. Nothing else cancels. So that's how I know that my answer is complete. Here's your third video quiz question. All right, now we're going to move into the harder problems. When you're multiplying rational expressions like this that are binomials or trinomials, you're going to need to factor them first. So in the denominator, I notice that the k squared minus 4k plus 3, that factors as k minus 3 times k minus 1. I'm going to cross through that original expression. In the numerator, the 1 minus k squared is a difference of squares, so that factors as 1 minus k times 1 plus k. And we go ahead and cross through that original expression. Now, let's cancel some common factors. The k minus 3 and the k minus 3 are common factors. K plus 1 and 1 plus k, those are identical, so they're common factors and they cancel. Now, I can do something with the 1 minus k, but I'm just going to go ahead and write down what I have so far. So right now what I have is in the numerator 1 minus k, and in the denominator k minus 1. Now remember, these are not identical expressions, but you can factor out a negative 1 from either one of them. I'm going to choose to do the numerator, and that's going to become negative 1 plus k, and in the denominator k minus 1. Now, the negative 1 plus k and the k minus 1 are identical, so those cancel, and you're just left with negative 1. That's your answer. Pretty cool. Alright, let's do a division problem. When you're dividing, remember you want to multiply by the reciprocal. So we're going to have 2d plus 6 over d squared plus d minus 2 times d squared plus 3d plus 2 over d plus 3. Now I'm going to factor all these. So that starting in the numerator on the left, I'm going to take out the greatest common factor, which is 2, and you're left with d plus 3. Cross through that one. The denominator on the left, that factors as d plus 2 times d minus 1. I'm going to cross through that one. The numerator on the right, that factors as d plus 2 times d plus 1. I'm going to cross through that. Now I'm going to cancel any common factors. So let's see, d plus 3, d plus 3, d plus 2, d plus 2. It looks like that's all I've got. So let me write down what I have. In the numerator I have 2 and then d plus 1. And in the denominator I have a d minus 1. And that's it. That's my final answer because nothing else will cancel. And here's your last video quiz question. Okay, our last example. This is a complex fraction, which just means the same thing as example 7, except it's written vertically instead of horizontally. So the first thing I'm going to do is change it and make it written horizontally. So this is actually x squared over 9x squared minus 4y squared divided by x cubed over 2y minus 3x. So remember, to divide by a fraction, you multiply by its reciprocal. So this is now x squared over 9x squared minus 4y squared times 2y minus 3x over x cubed. Now, 9x squared minus 4y squared, that's a difference of squares. So that factors as 3x minus 2y times 3x plus 2y. So I'm going to cross through that because I just factored it. Now I'm going to look for common factors and cancel them. So in the numerator, I've got x squared, and then I've got the x cubed. Well, both of those x squares are going to cancel with 2 of those from the bottom, so I'm going to change that exponent to a 1. Then the other thing, excuse me, got a message on my phone. The other thing is, you'll notice that the 2y minus 3x in the numerator is not the same thing as the 3x minus 2y in the denominator, but they are exactly the opposite. So what I'm going to do here in the next step is I'm going to factor out a negative 1 from the numerator, and that's going to become negative 2y plus 3x. Now in the denominator I have the 3x minus 2y and the 3x plus 2y, and of course that x is still there. Now the negative 2y plus 3x is exactly identical to 3x minus 2y. So what I have left is my final answer, and this is going to be negative 1 over 3x plus 2y times x. And we will leave our answer like that.